Hi, well, welcome everybody, both on Zoom and on YouTube, to this evening's meeting of the British Society for the History of Pharmacy. Baroni, welcome as well. I'm just going to make you a co-host. I can work out the dotted lines. There we go. Excellent. And just a few words first about the British Society for the History of Pharmacy. For those of you who don't know us, we're a small society, but we like to think we punch above our weight. We organise these talks. We switched from in-person talks to roughly one a month online. And it's really fantastic to see the international audience that attracts. And welcome to all of you. We always invite people, by the way, if you like to put a note of where you're from, where you're listening, into the chat bar. We hold an annual conference. We publish the open access journal, Pharmaceutical Historian. Do take a look at that. We've started offering research awards. We also subsidize courses for students. So if you like what we're doing, do have a look at our webpage, bshp.org, and have a think about joining us. But in any case, welcome this evening. Just a few housekeeping matters. As we go into the talk, it'd be great if you can turn off your video and audio as well. I'll invite you at the end to turn your video back on. It's nice to see people's faces, but for the moment, video and microphone off, please. Please post questions as they occur to you into the chat bar, or even a note that you'd like to ask a question, and I'll call on people at the end. I'll either read questions from the chat bar if you prefer, or I'll call on you to go live and to ask your question in person. If there's a technical hitch this evening, just wait a moment and then come back in on the same Zoom or YouTube link, and hopefully we'll have got it sorted out. And thank you to whoever turned closed captioning on. That's great. If you want to see a live transcript as we're speaking, if you click on the CC button down at the bottom, you'll be able to see subtitles being shown. And the talk is being recorded. We won't record, or at least we won't make public the discussion at the end. So if you don't want to appear, just make sure your video and microphone are off and you won't appear in the recording of the talk. So it's a real pleasure. I just need to keep an eye on the waiting room. I can see Brian is doing that. Thank you very much. It's a real pleasure to introduce tonight's speaker, Andreas Lardos from the Zurich University of Applied Sciences. Andreas is an immensely experienced ethnopharmacologist with a PhD from the School of Pharmacy here in London, loads of fieldwork experience in Cyprus and elsewhere, lots of publications, and expert in all aspects of medicinal plants, and therefore a fantastic partner in the project on popular Byzantine pharmacy, of which this little series of talks forms a part. This is a project headed by Barbara Zipser at the Royal Holloway, University of London, working with the Zurich University of Applied Sciences with the Royal Botanic Gardens Kew, but it's bringing together a whole range of different tools from philology, from ethnobotany, from botany, from pharmacy, from databases of plant names at Kew, run by Bob Orkin. Welcome to this talk, Bob, by the way. I see you're here in the audience. And taking this armory of tools and seeing if we can tackle what's one of the most knotty problems in thinking about medicinal plants in the past, which is the identity of the plants used to make drugs that are referred to in ancient texts. And I've worked in another project on this, the Mesopotamian clay tablets. I've learned a lot in this work on Byzantine pharmacy. I've also had a hand in similar work on Chinese texts. And I just how difficult it is to crack this problem. So it's a real pleasure to welcome Andreas to talk to us this evening. Andreas, would you like to share your screen with us?
Yes.
Perfect.
This one works. Okay.
Please go ahead.
Fine. Okay. Thank you, Mark, for the nice introduction, and thank you everyone for being here this evening. As Mark mentioned in the beginning, today's talk is concerned with the herbal materia medica in Greek texts, and more precisely how to elucidate these materials from a botanical perspective. So the overarching topic of the talk today is the identification of plants in written evidence of the past. I will present an overview of our research project, which is about a novel method to identify plants and minerals in historical texts based on examples of the Greek line of tradition. In this talk, I will only speak about the plants. We will not discuss the minerals, which are also a topic of our research project. We will look at the problem and why it is important to know the plants mentioned in such resources. I will present an overview of the methodology, and in the final part of the presentation, we will look at an example of a plant, and I will demonstrate how we do this comparative botanical analysis between modern and historical data. The basic problem when working with historical texts is that plants in these texts are reported by their common name. We don't have scientific plant names prior to the 18th century. So let's take a well-known example, chamomile. What would you say, which of the two plants is the correct chamomile? The plant on the left here, or the plant here on the right? Well, the answer is both plants are chamomiles, but in fact, the common name chamomile can refer to two different botanical species. So when we consult a database of plant nomenclature like Q's Medicinal Plant Name Services, and we query the common plant name chamomile, we get a list of associated scientific names. For example, the common names chamomile and common chamomile both refer to two different species, to Chamomillum nobile or to Matricaria chamomilla. On the other hand, we have then the garden chamomile, the English chamomile or the Roman chamomile, which all refer to Chamomillum nobile. And on the other hand, we have the common name German chamomile, which refers to Matricaria chamomilla. So this example illustrates that even in a seemingly straightforward case like a very well-known herb, like the very well-known herb chamomile, the situation is not as clear as one might expect. Numerous challenges are linked with the investigation of historical texts. Most common being linguistic or philological issues, or the identification or interpretations of the plant uses, of the medicinal uses mentioned in these texts. But we think that the identification of plants mentioned in written evidence of the past is one very complex and difficult issue. Often the only information about the plant we have is the plant name. As mentioned before, we have a pre-Linnaean plant nomenclature. Plants are reported by their common names, often in a local vernacular, which is not in use today. And moreover, depending on the region and time, the same plant name can refer to different plants. So what's the commonly applied method to identify plants mentioned in historical texts? How do we come from the historical plant names to the scientific plant names? Usually, this is done by consulting botany texts, dictionaries of plant names, glossaries of plant names, which on the one side list vernacular plant names and the associated scientific plant names. For plants of the Greek tradition, this would be the important works of earlier botanists, which studied the flora of Greece and other Eastern Mediterranean countries, with the aim to identify the plants mentioned in ancient Greek texts, like botanists like Sipthorp, Sprengel, Billerbeck, Lenz, and Fraas. But the crucial question to us is, how reliable are these identifications mentioned in the literature? Let's look at this famous example, silphium. The only clue we usually have are depictions on coins, which show a plant which very much looks like a species of the family of the umbellifers. It could, for example, be one of these tall-growing ferula species like Ferula communis or Pepsia garganica we find in the southern Mediterranean. In a study by Laurence Totling, 7 different identifications were reported for the substance silphium. But which one is the correct one? I think in this case, we probably will never know, because it seems that the respective plant is extinct in the region of origin, which was Cyrenaica in today's Libya. The plant is either extinct or locally eradicated due to overharvest in the past. So we think that existing methods of identifying plants in historical texts often prove inadequate. For example, to compare the plants used simultaneously in different cultures and regions, or to better understand the development of herbal medicine, or also to determine candidate plants for pharmaceutical research, because the certainty about the identity of the historical plants is limited. So why is it important at all to know the identity of plants mentioned in historical texts? Well, one reason, for example, is that plants in historical texts can be interesting starting points for drug discovery. One famous example, or perhaps the most famous example, is the discovery of artemisinin, a compound contained in Artemisia annua. Artemisinin and its derivatives represent the standard anti-malarial therapy today. UU2, which guided this project back in the 1970s in China, was awarded with the Nobel Prize in Physiology or Medicine because the discovery of artemisinin saved millions of lives. The compound artemisinin actually was discovered through the study of traditional recipes and especially of historical texts of Chinese medicine, especially this text from Gi Hong from the 4th century, the Handbook of Prescriptions of Emergencies, mentions applications of the plant Jing Hao, which leads to Artemisia species for the treatment of intermittent fevers. And interestingly for our case is that only the exact reproduction of the method mentioned in the historical text led to the successful discovery of the compound. The method described that the fresh plants should be soaked in water, then it should be wrung out, and the juice should then be ingested. So it's not a decoction as usually prepared in traditional Chinese medicine. A second reason why it's important to know the identity of historical plants is the reason of false identifications. False identifications can have a severe impact on patient safety. An example here is the case of aristolochic acid. Plants mentioned in historical texts are sometimes used in traditional medicines. For example, one of the fundamental herbs in Chinese texts of herbal medicine is the plant Stephania tetandra, the root of this plant, known as fangxi or han fangxi. However, in the past there was a confusion with roots of some Aristolochia species, which is a type of fangxi, but referred to with another name. And this confusion led to many cases of renal failure in Belgium and China, because this Aristolochia species contains carcinogenic and nephrotoxic aristolochic acid. Based on this background, we have developed a research project which is funded by the Wellcome Trust on the topic of plants and minerals in popular Byzantine pharmacy. As mentioned by Mark in the beginning, we're an interdisciplinary project team from the United Kingdom, from Israel and from Switzerland. The team encompasses expertise from diverse fields like archaeobotany, botany, ethnobotany, ethnopharmacology, but also geology, history and pharmacy, and of course, philology. The major aims of the project are to develop a novel methodology for the identification of plants and minerals based on an interdisciplinary approach. The aims also include to provide and to demonstrate and document the application of the methodology and to provide workflows and templates for further applications in other research projects. Special requirements were also that the methodology should be transferable, which means it should be able to apply this methodology to texts from other cultures or with another linguistic background. And moreover, the candidate plants which we find should be rated based on their likelihood of being the correct identifications. So the data should undergo some statistical evaluation. Our study object is the therapeutics of John the Physician, who is also known as Ioannis Archiatos. This text is a medical recipe text from the Byzantine tradition. Indicators in the text point towards its origin from late 13th century Cyprus. The reference text for the plants and minerals used in our study is the John's commentary edition. So this is the commented edition of the basic text of John. This edition is a vernacular Greek edition, contains detailed descriptions of how to prepare and apply the remedies. Recipe texts offer a unique gateway to invaluable empirical knowledge. For example, they provide a snapshot of the medical needs and possibilities at a certain place or time. Or secondly, the natural products mentioned in these recipe texts are very interesting for pharmacological research, exactly because they are based on practical knowledge. On the other hand, these texts are really difficult to gain access to, mainly because there are no descriptions for the plants mentioned. So the question arising then is, how did people know which plants are meant by these names? This made us to formulate two postulations for our case study. The first postulation is that Dioscorides' De Materia Medica is the reference text for the description of the plants mentioned in Byzantine recipe texts. This is based on the argument that De Materia Medica is the pharmacobotanical standard in the Greek line of tradition, and there is also evidence that De Materia Medica must have been available to writers of Byzantine recipe texts. The situation is best illustrated like this. We have, on the one side, we have recipe texts. These are dynamic compilations of daily medical practice. And on the other side, we have pharmacognostic reference texts like De Materia Medica, which are the guideline for identity and quality of drugs, and they have a more static sort of nature. So we think that the precondition for the botanical identification of plants in recipe texts is to have access to culturally associated pharmacognostic reference texts. Our second postulation is then that the herbal materia medica mentioned in Dioscorides' text has an Eastern Mediterranean emphasis. We know that the hometown of Dioscorides is Anasardos, which is a historical city in today's southeastern Turkey. And the plants mentioned in Dioscorides' text have a pronounced relationship to Anatolia, the Eastern Mediterranean region. Riedel found that Dioscorides most frequently mentioned places in the Eastern Mediterranean or in Anatolia as origin for his plants. Here we see, for example, Anatolia, Greek mainland, and Egypt are the places most frequently mentioned by Dioscorides as places of origin for his plants. So we think that botanical identifications of the plants mentioned in Dioscurides should be based on taxonomy books, mainly from the Eastern Mediterranean flora. So these are our two postulations. Let's look now at our methodology. To develop and test our methodology, we applied an experimental approach to assess the validity of botanical identities proposed in the literature for the plants mentioned in John's commentary, short JC. So for this case study, we relied on pre-existing identifications and tested their validity. A simplified flowchart shown on this slide illustrates the basic principle of our methodology. So it's important to understand that we have two data sets. We have on the one side a historical data set, and on the other hand, we have a modern data set. Historical data set is based on the plants mentioned in John's commentary. The modern data set are the pre-suggested candidate plants suggested in the literature. So these are the botanical identities for the JC plants proposed in the literature. Then for each data set, for the historical and the modern data set, we collect botanical and medicinal information. On the historical side, we collect this information from historical sources, like from JC's text itself and from the materia medica. On the side of the modern data set, we collect this data from modern botanical taxonomy books or medicinal information from medicinal databases or herbal medicinal books and so on. The core part of the method is then a comparative analysis of this historical and modern botanical and medicinal information. And finally, this delivers then our sample of validated candidate plants. So let's look at the methodology in some more detail. The first step consists in cross-referencing the JC plants with the plants mentioned in DMM. So in order to use the materia medica as the pharmacobotanical reference for the plants mentioned in JC, we have to determine the plants, JC plants, which are also contained in the materia medica. So again, we have our sample of JC plants. We consult the materia medica and cross-reference the plant names. And then we have our data set of JC plants contained in the materia medica. This data set is the starting point for establishing the historical data set. So in this step now, this step is about establishing the historical data set. Here we collect botanical and medicinal information for the JC plants. Again, we have our data set of JC plants contained in the materia medica. We consult Dioscurides and extract the plant descriptions of the respective plants into a separate database, JC plant descriptions according to the materia medica. This is our data set is the historical data set for the botanical analysis. And secondly, we consult John's commentary, our study object, and extract the medicinal uses of these plants into a separate database, which is the database of JC plants medicinal uses. And this is the historical data set for the medicinal analysis. In the third step, we define the list of pre-suggested candidate plants, which means we collect the botanical identities of the JC plants proposed in the literature. Again, we have here our set of plant samples from JC. We consult botanical literature, like, as mentioned before, dictionaries of plant names and glossaries of plant names, literature which reports Greek vernacular names together with scientific plant names. As mentioned before, these are the famous botanists, Sipthorp, Billebeck, Fraas, and Lenz, which we consulted, but we also looked at modern data from ethnobotanical field studies from Greece and Cyprus, which also report Greek vernacular names with scientific plant names. Then, based on this, we developed a list of scientific plant names associated with these JC plant names. In the next step, then, we validate these scientific plant names by consulting databases of plant nomenclature. And the final result of this step, then, is our validated list of pre-suggested candidate plants. This data set, then, again, is the starting point for establishing the modern data set. So step 4 then is about establishing the modern data set. Here again, we do exactly the same as on the side of the historical data set. We collect botanical and medicinal information for these pre-suggested candidate plants, but this time we collect it from modern resources. These are plant taxonomy books. We collect plant descriptions for these candidate plants from the taxonomy books, and this delivers our data set of plant descriptions for the pre-suggested candidate plants, which is the modern data set for the botanical analysis. And again, we look at the medicinal side. We consult reference texts of herbal medicine, publications of ethnobotanical field studies, and extract the medicinal plant uses of the respective plants. And we also consult databases which report data on human clinical trials and look up whether one of these plants has been tested in human clinical trials. And again, all this medicinal information is extracted into a separate database. And this database represents the modern data set for the medicinal analysis. So this step refers to establishing this final step is the key step of our methodology. It's the comparative analysis of historical data versus modern data. So on the one side, we have the botanical analysis, and on the other side, we have the medicinal analysis. On the botanical side, we compare the historical data set of the JC plants and the plant descriptions from DMM with the plant descriptions from the modern taxonomy books for our pre-suggested candidate plants. And on the side of the medicinal analysis, we compare the JC plant uses, the historical plant uses, with the modern plant uses of the pre-suggested candidate plants. This then delivers the results of the botanical or the medicinal analysis, respectively. And these results then undergo a statistical evaluation, which then delivers the candidate plants with validated probabilities. And this is exactly the key output of our method. We have a data set of candidate plants which are assessed based on their probabilities of being the correct identification. So in the remaining part of the presentation, we will look at the process of the comparative botanical analysis of modern and historical data. I will illustrate this process at one specific example. We look at the example of the JC plant Amaranthum. If we consult the literature and look up what botanical identities are proposed in the literature for this historical plant Amaranthum, it looks like this. First, we look up Dioscorides, and we see that Amaranthum is a synonym for the plant Elichrison, which is mentioned in Book 5, Chapter 57. Again, when we now consult the works of the earlier botanists, they suggest that Elichrison, or its synonym Amaranthum, can be identified with these three different plants, Pennisetum annum and the two Gnaphalium species, all from the aster family. When we now consult literature on distribution of plants, we learned that Panacetum annuum is not native to the Eastern Mediterranean. So actually, this plant drops out of the list. Panacetum annuum is mainly found in more western parts of the Mediterranean. And for the other two plant scientific names, we find that these are outdated synonyms. When we consult Kew's medicinal plant name services, we learn that these two species are outdated synonyms, and the currently accepted name refer to two species of the genus Helichrysum. When we then consult literature from the 18th century and look up for the Greek name Amaranthon, we find that in the 18th century, the Greek name Amaranthon was applied to a plant which in Dioscorides is called Aizon, or another plant which in Dioscorides is called Polion. So the Dioscorides plant Aizon is identified with two sedum species, which again are outdated synonyms, which according to MPNS refer to a sedum and the Pitosedum species. And the Dioscorides plant Polion refers to a Lamiaceae species. And finally, when we consult modern Greek literature, ethnobotanical studies, we find the name Amaranthon, or a semantically related name Athanaton, referring to three different Helichrysum species. Again, we have to check the validity of these scientific names and see that some of them need an update. They belong to other species or subspecies of the Helichrysum genus. Again, here we have a problem with the geographical distribution. Only one subspecies of this Helichrysum species is native to the Eastern Mediterranean, but not the species itself. So finally, we see that we have in all 9 different plants from 3 different families, which are suggested in the literature as identifications for the ancient plant Amaranthon. As we have seen in the previous illustration, the validation of the scientific names reported in the literature is an important step. We need to verify the scientific plant names with databases of plant nomenclature like Kew's medicinal plant name services. And we need to verify the geographical origin, in this case, the Eastern Mediterranean distribution of the plants. In our study, we used the flora of Turkey and Eastern Mediterranean and Eastern Aegean Islands by Davies and the flora of Cyprus by Mikkel. As shown in this table, from the 9 identifications proposed in the literature, only 3 were reported with valid scientific plant names. After the revision of the scientific plant names and the exclusion of plants not distributed in the Eastern Mediterranean, we remain with a list of 6 pre-suggested candidate plants. So 6 different taxa from 3 families are approved as pre-suggested candidate plants for the plant Amaranthon. On the next couple of slides, I illustrate a systematic comparison of ancient with modern plant descriptions. Here it's important to consider potential pitfalls in cross-cultural comparison. For example, we should keep in mind that translation is often involves interpretation. And we should also consider that ancient societies have a different understanding of plant anatomy. So for example, when Dioscorides makes reference to a seed or a fruit, it's not necessarily a seed or a fruit from the perspective of modern botany. These are the passages from Dioscorides for the plant Helichrysum and the synonym Amaranthon, the original Greek text from Wellman and the translation from Beck. And on the other side, we have here the plant description in the flora of Turkey from Davis from the 20th century. So we compare plant descriptions from the 1st century with botanical plant descriptions from the 2nd century. We don't go into details here, but move to the next slide and look at the comparison of these data. So the first step then here is to gather information from the historical text, which is, in this case, is the materia medica. The plant description in the materia medica can be broken down to 13 characteristics. So the text mentioned here can be broken down into 13 botanical plant characteristics. Dioscorides, for example, refers to the life form. He says it's a small shoot. And the habitus of the plant, it's an upright shoot with a white appearance. The leaves are similar to wormwood or to the leaves of wormwood. And the leaves are arranged in a circle. The leaves are narrow and they positioned at intervals. The flower is arranged in an umbel and its color is shining like gold. And then he also mentions other details about the root and ethnobotanical or details about the habitat, which are less important for our morphological comparison in this case. In the next step, we cross-reference the information in De Materia Medica with corresponding information in the taxonomy books, which in this case is the Flora of Turkey, and classify each comparison into each comparison of the individual characteristics into 4 categories of correspondence. We have the category of good match, partial match, no match, or absent. So here we have then the comparisons of the characteristics for the 3 candidate plants from the genus Helichrysum. We see that we have, for several characteristics, we find a good match. So the white appearance is also mentioned in the flora of Turkey for the Helichrysum species. In other cases, we have only a partial match. A partial match includes cases in which the information stated in the historical text and the taxonomy book seems to refer to the same characteristics, but it's not entirely clear due to the use of differing terminology or the application of different perspectives. The gray fields are empty categories which correspond to the category absent. This means that in the Flora of Turkey, the taxonomy book, there was no information, no reference was made for the characteristic described by Dioscorides, and therefore no comparison can take place. Here on this slide, we have the corresponding results for the other 3 candidate plants from the genera Sedum, Petrosedum, and Teucrium. We have also some cases where we find a good match, but several others where we have no match. So for several characteristics, we found contradictory information between De Materia Medica and the modern taxonomy book. For example, according to the Flora of Turkey, the Sedum and the Petrosedum species don't have a white appearance. They are bright green or reddish green, and therefore we have no match in this category. Although it's not part of our methodology, but to make a test and to check the significance of our results, we can make a cross-check with plant photographs, if such are available at all. Here I've selected the 2 examples, the two crystal-classic candidate plants, Helichrysum italicum and Teucrium pollium, and now we look how well the plant descriptions in Dioscorides fit with these plant photographs. So Dioscorides said that the plant has a white appearance. White appearance usually refers to plants of an olive green, whitish color, which is quite compliant in both of the species. And Dioscorides says that the flowers are arranged in round umbels, which is also more or less compliant in both of the species. He also says that the foliage is arranged in a circle. This is nicely seen here and also very nicely seen here in the teucrium case. And the leaves are said to be narrow, which is also the case here and here. But the difference is that the color of the flowers in the round umbels shines like gold. This is only the case for the Helichrysum species, but definitely not for the teucrium polium species. So the umbels are not shining like gold. This is kind of a criterion of exclusion then. In other words, there is a low likelihood that teucrium polium then is the plant meant by Dioscorides. The last step is then the statistical analysis of our results for the case Amaranthum. We want to know the likelihood of each candidate plant for the plant Amaranthum of being the correct identification. The table shows the distribution of the botanical characteristics compared between the historical and the modern data set over the 4 categories of correspondence: good, partial or no match, or the category absent. And we see here that the 2 first Helichrysum species have a high likelihood of being the correct identification. The third one, the 3rd Helichrysum species, is only a moderate likelihood. The other 3 plants have a low likelihood because we only have a few cases where we have a good match, but several cases we have a no match. And this places the candidates into a category of very low likelihood. So the conclusions for this case, for the case Amaranthum, there are only 2 of the 6 pre-suggested candidate plants which achieve the comparatively high likelihood. The 2 plants, Helichrysum italicum and this subspecies of Helichrysum stoechas, can be approved as validated candidates for the plant Amaranthum. We come to the final slide of the presentation. Some results of our study are still outstanding, as for example, the integration of the data of the comparative medicinal analysis, and also the statistical evaluation of the complete data set of validated candidate plants has not yet been completed. Still, we can draw some preliminary conclusions. First of all, it's clear that the precondition for the application and also the transferability of our novel methodology is the availability of historical resources which provide detailed plant descriptions. In our case, this was the materia medica. Another precondition is on the side of the modern data set. We need modern plant taxonomy works which cover the flora of the respective region, in our case, the Eastern Mediterranean. Under these preconditions, our interdisciplinary methodology enables to reassess pre-suggested identities of plants mentioned in texts of the Greek line of tradition, and it allows to determine candidate plants with increased precision by simultaneously providing a measure of confidence for the identifications established. Of course, the power of the comparative botanical analysis to produce significant results is dependent on the extent and adequateness of the botanical information available in the historical as well as in the modern resources. These are the references mentioned in the presentation, and I thank you for your attention.
Thank you very much, Andreas. If you just unshare your slides,
Right.
I will stop the recording if I can. Here we go.